All right, so let's keep going. Now that we know the definitions, what if I tell you that you already know machine learning? You just didn't know that it was machine learning. Okay. So imagine that we have a bunch of houses in a small geographical area, and we wanted to predict the sales price of that house. Okay, sales price of that house. So what I've plotted in this picture on the right here is, on the x-axis we have the square footage, and on the y-axis there are sales prices. Now each dot is a house that was sold, and this is part of a counter record. So this is what we have, right? Each dot is the sales price of house. Now, what we could do is we could draw a line. It's called a regression line. This is that red colored line in the middle, and we can draw this line such that the overall error is minimal. Okay, so we draw a line. Overall error is minimum. So now what we could do is we can estimate the equation of that line, and then this is again basic high school math, right? Y equals mx plus c, where y is the sales price of the house, m is the slope, how sloping that is, x is this square footage, and then c is the y-intercept, right? So we can easily calculate these values of m and c, and then this is the equation of that line. Now, if you have an unknown house, or if you want to put your house on the market, and let us say the square footage is 3,500 square feet, we can just either plug in that value of x into this equation, or we can simply go from here, see where this line intercepts, and then you can estimate that the value of your sales, the target sales price should be about $321,000. So here's an example where we have used machine learning to predict the sales price of a house based on the county records for that small geographical area. So this is the simplest machine learning model. It's actually called linear regression. So you may tell me that, Milind, the sales prices are not actually fixed. It may have a plateau, it might peak, right? You are correct. It doesn't necessarily have to have this linear relationship. In fact, those models are called polynomial or polynomial fit, where you can have higher order terms of x and x square or x cube and so on. So instead of having a linear relationship, you can have a non-linear relationship. So that is called polynomial fit. You may also say that, Milind, the sales price of a house is not just dependent on the square footage. It might be dependent on the number of bedrooms, the number of bathrooms, what is the lot size, and the type of construction, and so on, right? If you're saying that, you are absolutely correct. In fact, most real applications will not just use one feature. And in fact, there is a model for it. It is called multivariate, where you're doing regression on multiple variables at the same time. So you just learned basically 3 or 4 models right now, right? Linear regression, polynomial fit, multivariate. These are 3 simple algorithms in machine learning, actually. Okay, so now let us try to put this example in the context of a machine learning workflow. Okay, let's try to put this in the context of a machine learning workflow. So let us say you have in your organization, you're trying to deploy a machine learning project, or you are an artist and you want to do some prediction of what should I put on this price of this art, or whatever your area of work is. These are the 4 standard steps that you will have to follow. If you take these 4 steps, right, and if your objective of this training was to have that initial familiarity, you can check that box. Okay, so stay with me for the next 1 or 2 minutes, and this picture will be very, very clear. So again, we look at the same example. Let us say you have 100 houses in a small geographical area, right? 100 or some number. So the step 1, what is the step 1 we do? Step 1 is we split the house randomly into 2 sets. Okay, one is called a training set. Usually it is 80% of the data, and the testing set, which is usually 20%. It could be 90-10, 95-5, 70-30. It doesn't matter. Okay. 80-20 is a very common number. So step 1 is split the data, but we are doing this randomly. So it's not like the first 80 we are putting in the training set and the last 20 we are putting that. It's randomly. Okay, so there's no bias. Step 1. Then step 2, we do the exact same thing that we did before, which is for that training set, which is those 80 houses, right? We plot and then we create this regression line. Now, in data science speak, they'll say, oh, we have developed a model in machine learning. But now, they're just putting an equation. And in fact, you don't even have to write that equation. The program will do it for you, right? Did you see me write any equation in the deep learning magic show? No, right? So we are fitting the data. I'm just quote unquote like data science speak. So now you folks can speak like a data scientist. We are fitting the data. All that means is you're creating this regression line and identifying the equation of that line. That's it. Okay, so that's step number 2. But we are doing it on the 80% of the training data. Got it? Okay, so once we do that, now what we do is we use this 20% of the data that we had kept aside, right? Random, again, it was random. Now remember, even for that 20%, we had done the sales price of that house, right? We knew about the sales price. So now what we are going to do is we are going to create 2 columns. In one column, we will predict the value of the house based on our model, or in this case, the simple equation. And another column, we have the actual house value. And now we can compare, right? Some houses will be slightly higher, some will be lower, and you can just calculate the mean square error or something between the prediction and the actual values of the houses, right? And that's when you'll realize that, oh, you know what, we should have added not just the square footage, we should have added the number of bedrooms or bathrooms or lot size or whatever that scenario is in your area of work. If you're an HR, if you're trying to identify resumes and you have 300 of them, you only have time for 5. Machine learning can help you sort out that data. In fact, actually many tools actually use machine learning. Okay, so once you have done this step number 3, what you've done is you have fine-tuned the model to improve accuracy of prediction, right? So fine-tuning in this case is changing the model parameters, maybe adding more features or more columns or more data. So you're fine-tuning to improve the accuracy, but how we are doing it? Using that 20% test data that we had kept aside, right? Which the model had not seen. Okay, so that is step number 3, test accuracy of the model. Once this, and by the way, this term is called hyperparameter tuning. So if you're speaking to a data scientist, they may, oh, I have to do this hyperparameter tuning. Now you know what it is. It's as simple as tweaking the model to improve accuracy. That's all. Okay. Then step 4 is making predictions. So if you have new houses in the market, or if you want to predict, you can just plug in that in your new model, new refined model, and you can make predictions. So these are the 4 standard steps in any machine learning application. I'll just repeat. Split the data randomly, develop the model on training set, improve accuracy using testing set, and last 4, which is making predictions. That's it. 4 simple steps. You can remember them. So if you are coming in cold and you wanted to just be aware about AI and machine learning, I wanted you to be aware about the definitions that I covered. And I wanted you to be aware about these 4 steps. So if you are clear on these 2 things, I think you should say you have met your minimum objectives of spending 1 hour with me.